So a final word on comparing position time graphs and velocity time graphs. I've generated a file here where showing you various scenarios of how a V versus T turns into a D versus T and vice versa. So we're going to focus on these two right here. So let's take a look at the dashed line. So when we look at the dashed line on this V versus T, you'll notice that the slope on the V versus T doesn't change. So on a V versus T, that implies that we have constant motion. And on a V versus T graph, that constant motion is represented by a positive slope. And again, the reason why. The velocity from this graph equals the slope on that graph there. So since we have a constant velocity here, that means we have a constant slope here. Now let's take a look at this solid plot. So on this one, the velocity is constant as well, but it's lower, and hence the slope on this graph is lower. The fine dotted lines, we have constant negative velocity, and hence a negative slope on the D versus T. Now let's focus on the V versus T when we have a positive slope. So our dash line is sloping up, which means that the velocity is increasing. So if the velocity is increasing, that means the slope on the corresponding D versus T must be increasing as well. And since this is a positive slope, that means positive acceleration, which means we should be getting part of a smiley bit or positive parabola. So going down here on the D versus T, and that's indeed what we have. There's your smiley bit. Now let's compare this one. Still, we have a positive slope, therefore positive acceleration. It's just not as steep. So on the corresponding graph, we should also have a smiley bit, but with a more gradual increase. And then when we look at the final plot of the V versus T, here the slope is negative, so therefore we have a negative acceleration. So that should translate to a frowny bit or a negative parabola. So let's focus on this one. In this case, we have a change in direction. Our velocity goes from positive to 0 to negative. That means the entire time we are accelerating in the negative direction. So now let's compare that to our D versus T. So like I said, at the beginning, we have a positive velocity, which represents a positive slope. Then we're at rest, which is why we have a slope of 0 at the top, and then a negative velocity, negative slope. So we go from positive slope, which is positive velocity, to less positive, to 0, which is right there, to negative, to more negative. And in case you're wondering, this is what a ball would look like when thrown up at an angle. It makes a parabola, or this is what we call projectile motion. And let's take a look at this example. So the slope through the entire time is positive. So we have a positive slope at the bottom, positive slope in the middle, positive slope at the end, and the slope for the entire thing is the same. So on a V versus T, when you get positive slope, that means we have positive acceleration. So that means we're going to have a smiley bit, but look the way it's got to be shaped. Down here, the velocity is negative, then it's 0, then it goes positive. So on our D versus T, our slope must go from negative to 0 to positive. And lo and behold, that what we have. We have a negative slope because we have a negative velocity. In the middle, we have a slope of 0 because the velocity is 0. And at the end, the slope is positive. So we got our smiley bit. Okay, so now the next challenge. We have a combination of different types of movement going on. So what we have here is we have constant motion and accelerated motion. So let's label each section. So that's A, B, C, D, and section E. So let's take a look at section A. In section A, it's a constant slope. That means we have constant motion. So the slope is positive. So here we have positive constant motion. Now let's take a look at section B. We're going from a positive slope to 0 slope. That means we're going from a positive velocity to 0. This is negative acceleration. Section C, the slope is 0 throughout the entire thing. If the slope is 0 throughout the entire thing, that means we are at rest. And then section D, it's curved up, going from a slope of 0 to a positive slope. That means we have positive acceleration. And in the last section here, section E, the slope is unchanging and it is positive. So we have constant positive motion. So let's see what that's going to look like. So on our graph, on our V versus T, we have constant positive motion, and there we have it. The speed or velocity in this section is positive. Then we had negative acceleration, and there we have it. Negative acceleration down to rest. The next section is rest, and rest is what we have. Next, we have positive acceleration, and then constant positive motion. And here's the other thing to note. The slope in section A is the same as the slope in section E, which is totally in line with what we have on our V versus T graph. The speed in section A, or I should say velocity in section A, is the same as the velocity in section E.